Okay, this is a review of all of the different types of namings we have done. So first, starting with potassium, or just basic ions. When you're naming basic ions, like an ion like potassium, you're just going to call it's just super basic because it's just a cation. It's just a positive ion. Potassium is just known as K+. So technically, its name is really very simple. It's just potassium ion. So K+ comes out to just be potassium ion. Or technically, I'm getting that wrong, potassium cation. That's it. Now, anions are a little different, but not ridiculous by a ridiculous amount. They're just negative ions, so you would call something like bromine a bromide anion. Notice the IDE ending that you add on to any anion. You don't need that with cations. So just the IDE ending with anions. Now moving on, when you're going to start combining these cations and anions, you have to figure out how you're going to combine them in a way to balance them out. All compounds have a neutral charge, so when you're putting the compound together, you want to make sure the charge stays neutral. So when you're combining a magnesium cation and a bromine anion, you're going to get something different. So again, this is what you want to look at here are the charges. So magnesium is always a 2+ charge. It's in group 2 of the periodic table, so it's always 2+. Bromine, on the other hand, is always -1. It's in group 17, so it is always a -1 charge, always. So when you put these two guys together, one thing you can do is you can do the crossing method, which is just basically crossing over the charges and sending them to each other. So it's like you bring down magnesium, and it would be Mg. You're going to bring the superscript to subscript 1, bring down the bromine. You take this 2, bring it down from a charge to a subscript. So this compound becomes Mg2. Personally, I like just looking at the charges and balancing them out. So when you have magnesium that's 2+, that means you just take your 1 magnesium, and you know you need 2 minuses from a bromine. You need 2 bromines to balance out that 2+ charge. Excuse me, let me fix that. Because you have 2 minuses and you got 2 positives over here. So it has all balanced out. 1 magnesium is 2+, 2 bromines give you 2-, so it balances. Again, the whole idea here is to get a neutral charge. But whether you do the crossing method or balance down charges, either way works just fine. Now moving on, another example is what if you're going to combine barium and oxygen. So in this I typed out barium ion and oxygen ion, but you can just think what if we're going to combine barium and oxygen. You have to realize what their charges are based on what groups they are in. So barium is in group 2, that means it has a +2 charge. Oxygen is in group 16, so it has a -2 charge. So first you want to write the ions, especially when you're first just learning how to do these types of combinations. So always write out the ions, always. It makes things a lot easier when you're just starting this out. Now if you notice, if you do the crossing method, you would get Ba2. Again, that's just crossing these charges, bringing them down. You get Ba2O2. And what you want to do is you want to translate that to just all you need is a Ba and an O. That's what you want to translate that to. If you look at it, you would also notice that the charges actually balance out really well. +2 balances out versus -2, so you would get the same thing, BaO. 1 Ba cancels out the charges in 1 oxygen, and BaO is totally fine. Works out very well. That's a pretty simple example. Now, when you get to things like lead, lead is a transition metal that you find in the D block. You find transition metals not only in the D block, but some of them are also in the P block, like aluminum, germanium. Those are other transition metals. Whenever you're dealing with a transition metal, you have to, and you're going to name it, or make the compound and then name it, you have to use a different system. Because the problem is transition metals are, they form different types of ions. They are not always the same ion like everything in the S block or everything in group 1 and 2. Everything in group 1 and 2 is extremely predictable. But transition metals, they go through transitional states, they are unpredictable or not as predictable. So something like lead and sulfur. Lead has a couple options for what it can form. Lead could form a couple different types of ions. But sulfur is always the same thing. Sulfur always forms a 2- or -2 ion. Always. It's always that. So what you have to do with a lot of these is you have to figure out what charge does lead have to be to balance out the sulfur. So if you wrote out just if you write out that, this Pb and S, that tells you you would name it a very specific thing. Because you're saying that this Pb here is 2+, because it has to balance out the 2- in the sulfur. So you would name this lead 2 sulfide. Lead 2 sulfide. Now, basically, you're using these Roman numerals to identify the charge on your lead. And this is called the stock system. So whenever you have a transition metal involved, you can use the stock system. Now go back to the one we just did, Ba and O. With something like barium and oxygen, you don't have to use the stock system. When you're naming this guy, when you are naming this barium and oxygen combination, you just call it barium oxide. That's it. You keep your IDE ending, and you just call it, you just throw the barium in front. Barium oxide. You do not need the stock system with barium, specifically because barium is very predictable. Barium is always a -2 ion, so you don't have to outline that in the name. And going back to the previous example before that, Mg2, if you're going to name this guy, it's just magnesium bromide. Again, IDE ending. And again, you don't need the stock system because magnesium is a very predictable element. It's always +2. Always. And bromine's predictable too because it's always -1. So barium oxide, magnesium bromide, and then we get to lead sulfide where you use your stock system. Now next comes polyatomic ions. With polyatomic ions, you have to start remembering and memorizing some of the most common types. So some of the most common types of polyatomic ions are phosphate ions, which is PO4, and it has that. This whole ion has a charge of 2-. Sulfate is SO4, and this guy has a charge of 2-. And nitrate is NO3, and this whole guy has a charge of -1. What you want to keep in mind is that basically a polyatomic ion, if I were to draw the Lewis structure of it, just the like what the molecules are kind of doing, you got to realize that what you're looking at is just this big compound that likes to stick together. It likes to stay the way it is. That's what you're looking at there. And it just these are just units that we call polyatomic ions. And this polyatomic ion would have brackets around it after you draw the Lewis structure with a negative. And that's the, this negative that you have over here in the formula. So when you are doing types of namings with polyatomic ions, this is why you want to remember them. Because if you notice, this is phosphate. Not phosphide, phosphate. The AT ending tells you that is a polyatomic ion, and you either have to look it up, or if you're in the middle of something, you got to remember it. So, okay, so let's breaking this down step by step. How would you get from name to formula? So copper 1 phosphate. Okay, so the Roman numeral 1 tells you this copper is a +1 charge. The phosphate tells you this is a polyatomic ion, that's a PO4, and that ion has a 2- charge. You basically just have to remember that or look it up. So to get the formula for this guy, you have to know, well, 2- charge, you can either do the crossing method and bring the 2 over to copper, this 1 over to phosphate, or you have to realize that 2 coppers have to balance out the 1 phosphate. So that gives you Cu2PO4. If you're going from the formula to the name, depending on what it is, it could be easier or more difficult. This depends. In this case, you have to recognize you still have copper. Again, these are transition metals, so your name, copper is a transition metal, so your name, just like this one up here, is going to have a Roman numeral. The name has to have a Roman numeral in it to identify the copper. Now, with something like, whenever you have a transition metal in a name, if it doesn't have a Roman numeral, you can assume it's 1. So in this case, our polyatomic ion is OH. OH is also known as hydroxide, and it's OH-. Since you have 2 OHs, that's 2 negative charges. In this case, it's a little different. Since you have 1 copper and 2 OHs, that 1 copper must balance out the 2 negative charges. So this has to be a copper that's a 2+ charge, or a +2 charge, whereas these are 2 negative charges here. So this would come out to copper, Roman numeral 2, hydroxide for that polyatomic ion. That's the name of this guy here, hydroxide. And you just have to remember that name, or look it up. Now, molecular compounds. Molecular compounds are basically compounds that don't have metal in them. So the most, like a very, very common one is carbon dioxide. Everybody's heard of carbon dioxide. That's just CO2. We call it carbon dioxide. You want the di to outline 2 oxygens. So dioxide. There are some basic rules to naming these molecular compounds. You can also call them covalent compounds. One of the rules is you wouldn't call CO2 monocarbon dioxide. You wouldn't call it monocarbon. Whenever you have just one of a first element in a compound, you basically just call it just the element. You don't have to throw a mono there, so that's not necessary. Never do that. That's just one of the rules, and there's a couple other things to it. I'm not going to go into it. I'm just going to try to do these examples. So BBr3, how would you name this guy? Well, again, you're not going to call it monoboron. You don't have to do that. It's just one boron, so just call it boron. There's 3 bromines, so you're going to call it tribromide. Keep the IDE ending. Keep it. Those stick on these types of compounds that don't have metal in them. Now, there are a bunch of different types of prefixes. I'm not going to list them out here. You can look them up. But there are a bunch of different types you use for different numbers of these compounds. This one here, N2. Since you have 2 nitrogens, you'll call it dinitrogen. And this first element does not need the IDE ending. That's not necessary. And then you'll call it trioxide. So dinitrogen trioxide. Going the other way is actually, in my opinion, it's a little easier because you have, if you're familiar at all with the prefixes, and you'll just look at the element, and if you're familiar with the symbols, it's pretty easy to put together. So you look at this and you say, okay, tetraphosphorus triselenide. Tetra is 4. The symbol for phosphorus is just P. Tri is 3. Selenide is Se. So that's just the formula for this guy is just P 4 Se 3. Di is 2. Silicon's Si. Hexa is 6. Bromide is just Br. So that's Si2 Br 6. Tetra again 4. Sulfur is S. Di is 2. Nitrogen is N or nitride. So that's S4N2. And there you go.